Greetings everyone and welcome to Electronics. My name is Fatima Garba Yusuf and I'm here to walk you through the Chemistry 2020 Jamb past questions and answers. So the first question here says, which of the following acid is a weak acid? Which of the following acids is a weak acid? So you're given a number of options. Here we have A as H3PO4, that's phosphoric acid. B is HClO4, the chloric acid. C H2SO4, the sulfuric acid, and D HNO3, the nitric acid. Now among these options, H3PO4, which is the phosphoric acid, is actually the one which is a weak acid because it doesn't ionize completely in a solution. It doesn't dissociate completely to give hydrogen ion. So your answer here is A. The second question says, to what volume should 250 cm³ of 2 mole per dm cube hydrochloric acid be diluted in order to obtain 0.1 mole per dm cube HCl? So this is a basic example of a question where you need to use the Kava formula, that's CAV equal to CBVB, when you're trying to balance the concentration and the volume of a solution. So what you're going to do is we're going to do a quick calculation. The formula is commonly called the Kava formula. This is because you have CAVA equal to CBVB. This is telling you that the concentration, when you change your concentration, it will result in another change in volume, or you can say that the concentration and the volume are inversely proportional. So when you increase one, you decrease the other, and when you decrease one, you increase the other. So here you were given your initial concentration as 2 mole per dm cube. That's your Ca, 2 mole per dm cube. You are given your Va as 250 cm³, and you can convert this to dm cube to give you 0.25 dm³. Then you're also given your Cb, which is 0.1 mole per dm³, and you were asked to find your second volume, that's your Vb. So to do that, you simply multiply the A's and equate them to a multiplication of the B's. That's, you will have 2 multiplied by 0.25, which will give you 0.1 multiplied by Vb. So you now divide both sides by 0.1. Of course, when you multiply 2 and 0.25, it will give you 0.5. And when you divide by 0.1, it will simply give you your Vb to 5 dm³. So you go to your options and you see your 5 dm³ as option D. So that's your answer. Then the third question says, which of the following reactions will benzene readily undergo? You have A, polymerization, B, addition, C, substitution, and D, hydrolysis. Now the one which benzene will readily undergo is substitution reaction. This is because other reactions such as addition will disrupt the structure of benzene. So it will readily undergo substitution reaction, which is C. Then your fourth question says, consider the process represented by the following chemical equation. You have sodium chloride in solid form plus water in liquid form, given dissociating to give you sodium ions and chlorine ions, both aqueous, and then some solid sodium chloride. Now what this is implying is that when you dissolved your salt, your table salt, in water, it dissociated to give you sodium ions and chlorine ions, but there was a remainder of solid salt. So they asked you that the equation represents A, saturated solution, B, unsaturated solution, C, solids dissolving in a solvent, D, fully dissociated salt. So of course this is a solid dissolving in a solvent, but what this equation really shows is that this is a saturated solution, and by saying it is a saturated solution, we are implying that the complete solute didn't dissolve. That's why we have a remainder of the sodium chloride here. Hence, it is not a fully dissociated solute, and it is not merely a solute dissolving in solvents, and it is not an unsaturated solution, but a saturated solution. That's why we have some solid crystals. So your answer is A. Then the fifth question says, electrons always occupy the lowest empty energy level. Is a statement of A. AFPAL principle, B. Hund's principle, C. Periodic law, and D. Pauli exclusion principle. So actually, AFPAL is German for building up, and what the principle states is that indeed electrons always occupy the orbitals from the lowest to the highest, that they occupy the lowest empty energy level first. Therefore, your answer is A. AFPAL principle. Then question 6 says, the following prevents iron from rusting except A. tin plating, B. galvanizing, C. electroplating, and D. vulcanizing. Actually, there are a number of ways through which you can prevent iron from rusting, and among them we have painting or electroplating, galvanizing, and even tin plating, that's coating tin. But then vulcanizing is not even associated with iron. Instead, it is associated with rubber. So since we're asked to remove the exception, your answer is D, vulcanizing. Next, you have question 7, which says, which of the following processes does not involve redox reaction? You have A. rusting of iron, B. combustion of fuels, C. decomposition of limestone, and D. bleaching of dye. So when you observe all these processes, the one that doesn't involve redox reaction is the decomposition of limestone, and the reason is that the oxidation number of the atoms involved in the reaction doesn't change. So your answer is C, the composition of limestone. Next is question 8, which says, which of the following quantities represent 965 coulombs of electricity? You have your options all in moles of electrons. So this is indirectly asking you to just convert 965 coulombs of electricity into electrons or moles of electrons. So we're going to do a bit of calculation. 96,500 coulombs actually represents 1 mole of electron. But then you were given 965 coulombs and you don't know the quantity. You can name this E, so you can cross multiply. You have 96,500 times E is equal to 965 times 1. So to find your E, you divide both sides by 96,500. You don't have to worry about multiplying and then dividing. Of course, it's Jamb and you don't have much time, nor do you have a sophisticated calculator. So you cancel this and you're left with your E, which is equal to, you cancel 965 here, goes through 1 time, then here it will be 100 times. So you're left with 1 over 100. 1 divided by 100 will give you 0.01 mole electron. So you consider your options. You have your D as 0.01 mole of electrons. So that's your answer. Then question 9 says, sulfur 4 oxide differs from carbon 4 oxide in that it A. is denser than air, B. it dissolves in water to give an acid, C. reacts with alkaline solution to form salts, and D. combines with oxygen to form a higher oxide. So one of the characteristics of sulfur is actually that it forms different oxides. So we can say that in one of the ways through which sulfur 4 oxide differs from carbon 4 oxide is that when it combines with oxygen, it can form a higher oxide. So your answer is D for question 9. Then question 10 says, which of the following turns wet starch iodide paper to blue-black? So when you've paid attention to your tests of various elements, whether be they metallic or non-metallic, you will know that chlorine, one of the properties of chlorine is that when you add it to wet starch iodide paper, the iodide ions on the paper are oxidized to iodine, and the starch actually reacts with it to give a blue-black compound. So your answer here is B, chlorine. Now we move on to question 11, which says elements S and T have half-lives of 3 × 10⁻³ minutes, that's 0.003, right? And 3 × 10⁻² minutes, that's 300 minutes respectively. So they asked us that this means that A, S is more stable than T, B, T is more stable than S, C, S and T have equal stability, and D, S is slightly stable than T. So what half-lives actually indicate is that they show how stable an element actually is, because that measure, or that half-life, is a measure of how long the element can stay without decomposing or transforming to another or breaking down. So we are told that S breaks down every 0.003 minutes, while T breaks down every 300 minutes. So of course that shows that T is more stable than S. So your answer is B. Then your question 12 says, which of the following polymers is thermoplastic? Here you were given options: A, perspex, B, cellulose, C, bakelite, and D, proteins. So a common example of thermoplastic polymers is polymethyl methacrylate, and its other name is perspex. So you can see our answer here is actually perspex, which is A. Then question 13 says, sodium hydroxide is industrially used in the manufacture of A, sodium chloride, B, plastics, C, soap, and D, margarine. So one of the industrial processes where sodium hydroxide is extensively used as a base is in the soap industry, where it is used to react with triglycerides to form in the saponification reaction. So our answer here is C. Then the 14th question, which says, which of the following is an air pollutant commonly found in industrial areas? We have A, ozone, B, sulfur oxide, C, lead dust, and D, hydrogen chloride gas. Now, one of the pollutants, air pollutants, that's held responsible for a lot of air pollution is actually sulfur oxide, and it is found mostly in industrial areas. So our answer here is B. Next, we have question 15, which says, the greenhouse effect is associated with the presence of excess A, hydrogen sulfide, B, nitrogen 2 oxide, C, carbon 4 oxide, and D, carbon 2 oxide. So one of the reasons, or the major reason for greenhouse effect is when there's a lot of combustion and the burning of fossil fuels, and that's actually a process that leads to the release of carbon dioxide into the atmosphere. Therefore, you can say that the greenhouse effect is associated with the presence of excess carbon dioxide, which is C. So question 16 says, in which group of the periodic table will an atom with electronic configuration 1s2, 2s2, 2p5 be found? For you to determine the group of any element in the periodic table, you take a look at the number of its outermost electrons. So here we have a field orbital of 2, and then we have 2 and 5 making 7. Therefore, the group of this atom is group 7. That means it's a halogen. So your answer here is D7. Then question 16 says, which of the following processes or process takes place during distillation? As you can see from the options, one of the options gives only one answer. That's why there's an option for the answer to be singular, while the others are plural. So you have I absorption, II desorption, III condensation, IV evaporation. So actually distillation is more or less a heating and cooling process. Therefore, the processes that are involved in it are condensation and evaporation. That's III and IV. So your answer here is D. Then question 18 says, the oxidation number of manganese in this compound is dash. So here we're going to do a quick calculation. You have this as your compound and it's neutral. So for you to find the oxidation number of manganese, you substitute the oxidation numbers of zinc and oxygen, equate them to 0 since it's a neutral compound, and you find your manganese. So you can represent your manganese with M. The oxidation number of oxygen is -2 and the oxidation number of zinc is +2. So you substitute all this. And you have +2 for zinc plus M for manganese, but then your manganese is 2, so you put this here, then plus 4 of your -2 for oxygen equal to 0. So this gives you 2 plus 2m minus 8 is equal to 0. You can take your numbers to the other side, leaving you with 2m here equal to plus 8 minus 2, that's 6. So you divide both sides by 2, leaving you with m is equal to 6 divided by 2, that's plus 3, since this is a positive value. Don't forget to put your positive sign or negative sign as it may occur. So your answer here is A plus 3. Then question 19 says, covalency is enhanced between atoms with A. Widely different electronegativity, B. Very close electronegativity, C. High electron affinities, and D. Low ionization potentials. So typically, covalency usually occurs between atoms whose electronegativity values are quite close. So your answer is B. Very close electronegativity. Then question 20 says, alkaline metals A. form covalent bonds with halogens, B. have their melting points, they're supposed to be melting points, decrease down the group, C. form oxides when reacted with water, and D. have their reactivities decrease down the group. So one of the characteristics of alkaline metals, that's group 1 elements, is that their melting points decrease down the group. So your answer is B. Then question 21 says, the gas produced when dilute hydrochloric acid reacts with barium trioxosulfates could be identified by its A. characteristic odor, B. ability to change blue litmus paper red, C. ability to turn lime water milky, and D. ability to turn acidified potassium permanganate colorless. So actually, when you react barium trioxosulfate with hydrochloric acid, you're left with barium chloride and SO2 and also water. So the presence of that SO2 actually gives a pungent smell. That means when you undergo this reaction, you will be able to identify the gas by its characteristic odor. That's your SO2 gas. So your answer is A, characteristic odor, your sulfur 4 oxide. Therefore, next we go to question 22, which states group 7 elements in their combined states are A, halogens, B, anions, C, halides, and D, cations. So actually group 7 elements are called halogens, but in their combined states they are called halides. So your answer is C. Next is question 23, which says if 100 cm³ of a saturated solution of copper tetraoxosulfate 6 at 120 degrees Celsius gives 40 grams of the salt on evaporation, calculate its solubility. Here we are going to use the formula for solubility to calculate solubility value for this scenario. We are given a volume of 100 cm³, which will convert to dm cube since our answers are all in dm cube. Then we're given a mass of 40 grams of the solids, and we need to calculate the number of moles of the salt using its atomic weight and its mass in grams here. So we'll do the calculation. So our compound of interest is CuSO4, Cu for copper, S for sulfur, and O for oxygen. We're going to calculate the weight of this compound using the given values. We have copper to be 64 grams per mole. We have sulfur as 32 grams per mole. We have oxygen, of course, as 16 grams per mole. We're also given a mass of 40 grams. Then we're also given a volume of 100 cm³. And this 100 cm³ can be converted to 0.1 dm cube. What we need to do now is calculate the number of moles, our N. And N is equal to M, small letter m over capital letter M, which is going to give us 40 over the total mass of the compound. The total mass of the compound will give you 64 plus 32, then plus 4 times 16 for oxygen. So when you add this all up, 64 plus 4 times 16 will also give you 64. I have to close this bracket here. 4 times 16 will also give you 64, and when you add it to the 64, it will give you 128 plus 32. It will give you 160. So you have 40 grams divided by 160 grams per mole. When you cancel your grams, you'll be left with mole. So your number of mole is going to be equal to 40 divided by 160. Of course, the 0 will cancel, and 4 here 1, 4 here 4. So you have 1 over 4, which is equal to 0.25 mole. Now your solubility is now going to be equal to N over your V, which is your volume, in dm cube. That's 0.25 mole divided by 0.1 dm cube. And when you divide this, it will give you 2.5 mole per dm cube. You now head off to your options and select the correct one. That's C, 2.5 mole per dm cube. Now question 24 says, consider the reaction represented by the following equation. You have hydrogen sulfide plus sulfur 4 oxide reacting to give water and sulfur. So we're now to ask, sulfur 4 oxide is acting as dash A, the hydrating agent, B, reducing agent, C, precipitating agent, and D, oxidizing agent. So this will be a redox reaction, right? Since we are having reducing agent and oxidizing agent as part of our options. So we'll now take a look at sulfur and see whether it was actually reduced or oxidized. If it was reduced, then it's an oxidizing agent. And if it was oxidized, then it is a reducing agent. So you can see here from SO2, we already know that the oxidation number of oxygen is always -2. So since we have 2 of it here, we have -4 for oxygen, implying that since this is a neutral compound, our S, the oxidation number of sulfur here, is +4 to cancel out the -4 of oxygen. But then here, the oxidation number of sulfur is 0 because this is a neutral. That means from 4 to 0, it was actually reduced. Therefore, it is an oxidizing agent in this scenario. So your answer is D. Now question 25 says, which of the following gases will diffuse fastest when passed through a porous plug? A, you are given of course your values of hydrogen 1 gram per mole, carbon 12, nitrogen 14, and O16. So what this is implying is that you are asked to calculate the masses of these options that you are given: propane, oxygen, methane, and ammonia. This will help you in determining which one will diffuse fastest, because lighter compounds diffuse faster. So I'm going to write out the formula of each of these compounds, and then we'll use these values in gram per mole to find the masses and then determine which is the lightest compound and which will hence diffuse fastest. So we have propane, oxygen, methane, and ammonia. Propane is, according to the formula for alkanes, prop stands for 3 carbon. So we have C3, and then the formula for alkenes is actually Cn and H2n plus 2. So 2n plus 2 in this case is 2 times 3, 6 plus 2, 8. So we have C3H8 for propane. And our oxygen, of course, oxygen is a diatomic molecule, so we have O2. Then methane, according to the alkane formula, meth is 1 carbon atom, while for your hydrogen, you have 2n plus 2. Your n here is 1, so 2 times 1 is 2, and plus 2 will give you 4. So you have CH4. Then ammonia, its formula is NH3. So you use the values of the masses of all the individual elements to calculate the masses. So carbon is 12, right? 12 times 3 will give you 36. 36 plus your 8 times 1 for hydrogen. This will give you 44 gram per mole. For oxygen, O is 16. So you have 16 times 2, which will give you 32 gram per mole. For methane, we have 12 plus 4 into 1. That's 16 gram per mole. And for ammonia, we have nitrogen to the 14. So we have 14 plus 3 times 1. That's 17 gram per mole. So of course, which is the lightest here? We have methane as 16, this is 17, this is 32, and that has 44. Our answer will be methane, which has the lightest mass. So our correct option is C, which stands for methane. So question 26 says, an alkanol which does not have the hydroxyl group bonded to carbon position 1 can be classified as A, primary, B, primary or secondary, C, secondary or tertiary, and D, tertiary. The answer here is secondary or tertiary, because they're typically the ones that don't have the hydroxyl group bonded to the first carbon. Hence, your answer here is C. And question 27 says, the reaction between alkane and halogen is by A, addition, B, reduction, C, polymerization, and D, substitution. Actually, the reaction between an alkane and a halogen is by substitution. That's how you remove one or more hydrogen atoms and you replace it by a halogen to give you an alkyl halide. So your answer is D, substitution. Next, we have the separation technique, which depends mainly on the solubilities of solutes at different temperatures, is A, sublimation, B, distillation, C, evaporation, D, crystallization. So A, B, and C actually all involve heating. but they don't really depend on the solubility of the solutes. But as for crystallization, it actually depends on the solubility of the solutes, as it's done in mostly saturated solutions. So your answer here is D, crystallization. Next is question 29, which says in an electrochemical cell represented as this one, zinc and zinc tetraoxosulfate 6 with a salt bridge, and then copper and copper tetraoxosulfate 6, which of the following statements about the cell is correct? A, the cathode slowly decreases in size. B, electrons flow from anode to cathode. C, oxidation occurs at the cathode. And D, anode slowly increases in size. So the answer here is, in any electrochemical cell, electrons usually flow from the anode to the cathode. So your answer here is B. Next is question 30, which says, what is the IPAC name of the following compound? We have CH3, CHCl, CH3, CH3. So actually, for you to name this compound better, it would be good if you could sketch it out in a spread out format. So I'll do that quickly. So you can spread this out to give you your CH3 as C surrounded by hydrogen, and then another C with hydrogen and chlorine, then another C with hydrogen and a methyl group, then with C and 3 hydrogen. So you can see we have a chlorine and we have a substituent. To name this, you can start from this, since we have 4 carbon atoms. Of course, the base name will have to be butane, 1, 2, 3, 4. Then in naming or adding the substituent, you start alphabetically. You have chloro, and then you have methyl as the alkyl group here. So you start by writing your butane, then you name this 1, 2, 3, 4, right? It will be 2 chloro, 3 methyl butane. Because this is position 1, position 2, position 3, and position 4. Chlorine is attached to position 2, that's why we have 2 chloro, and the methyl group is attached to carbon 3, that's why we have 3 methyl butane. So let's see which of the options is our answer. Our answer is C, 2 methyl 3 chlorobutane. The next question is, what is the concentration of the solution containing 1.4 gram of potassium hydroxide in 250 centimeter cube? We're going to follow the same process we followed when calculating solubility. That is, we are going to calculate the number of moles of potassium hydroxide, and we're going to divide it by the volume, which will convert to dm cube. So potassium hydroxide is KOH, and we're given the masses of potassium, hydrogen, and oxygen. So we are going to write it out here. KOH with K as 39, oxygen as 16, and hydrogen as 1. So your mass is going to be 39 plus 16 plus 1, which is 40 plus 16, and that's 56 gram per mole. So your number of, since we are given our M as 1.4 gram, your number of mole is going to be M over M. That's 1.4 gram divided by 56 gram per mole. So 1.4 divided by 56 is actually the same thing as 14 divided by 560. And when you divide this, 14 can go into 56 4 times. So you have 1 divided by 40. and that will be broken down into 0.025 mole. As for your volume, you were given a volume of 250 centimeter cube. That's 0.25 dm cube. Therefore, your concentration is going to be 0.025 divided by 0.25. Of course, you can see that this is a multiple of this. So, what you have is 1/10, and that's equal to 0.1 mole per dm cube. According to your options, your answer is C, 0.1 mole per dm cube. Now, question 32 says, which of the following species is the strongest reducing agent? The answer to this question is the iodine ion, because it is one that readily gets oxidized. So your answer is C, the iodine anion. Then question 33 says, which of the following solutions will turn blue litmus paper red? By this, it's asking us to identify the acidic option. We have KCl formed from potassium hydroxide and perhaps hydrogen chloride. That's a strong acid and a strong base. It will give you a neutral solution. For this second one too, what we're going to do is we'll try to identify the one which was formed using a strong acid but a weak base, such as D, where it implies that hydrogen tetraoxide 6 acid was actually used, but the base that was used wasn't either potassium hydroxide or sodium hydroxide, which are the most commonly known strong alkalines or strong bases. So your answer here is D, because if you use a tetraoxide 6 acid with a weak base, it will not be able to neutralize it completely, leaving you with an acidic solution. So your answer is D. Next is question 34. Which of the following compounds has an octane number of 100? Actually, the compound that has the highest value of octane number, highest quality, so to say, is 224 trimethylpentane, and that's B, option B. Then question 35 says, which of the following oxides can be reduced to the metal by hydrogen? You have A, calcium oxide, B, copper 2 oxide, C, magnesium oxide, and D, sodium oxide. Your answer is copper 2 oxide, as it can be reduced by hydrogen to form your copper metal and water. So your answer is B, copper 2 oxide. Next is question 36, and it's a question on empirical formula. It says an organic compound contains 53.3% oxygen, 6.7% hydrogen, and 40% carbon. What is the empirical formula of the compound? You're also given the value of the masses for hydrogen, carbon, and oxygen. So we are going to write this down. The compound is made up of carbon, hydrogen, and oxygen. And we're told that the percentage of carbon is 40%, the percentage of hydrogen is 6.7%, and the percentage of oxygen is 53.3%. So these are the percentages. What we are first going to do is we're going to divide each of these by their respective atomic masses. So we're going to divide 40 by 12 for carbon, 6.7 by 1 for hydrogen, and 53.3 by 16 for oxygen. So 40 divided by 12 will give us 3.333. 6.7 divided by 1 will give 6.7, while 53.3 divided by 16 will also give us 3.33. The next, what we are going to do is we are going to divide each of them by the smallest number. So we have a tie here. We have 3.3 here. We have 3.33. Nevertheless, we are going to divide by 3.33. divided by 3.33. Divided by 3.33. So of course this will give 1. This will also give 1. While this one will give us 2.0 something something, but you can approximately leave it as 2. So this implies that our empirical formula says we have 1 carbon, then 2 hydrogen, and then 1 oxygen. That's simply it. Our answer is C. Then question 37 says, consider the following reaction. We have aluminium in solid form reacting with oxygen in gaseous form to give aluminium oxide. So how many moles of aluminium oxide will be formed when 27 grams of aluminium react completely with oxygen? So this is the data given to you. What you're going to do is, you can see from the question, we asked how many moles of aluminium oxide will be formed when 27 grams of aluminium reacts completely with oxygen. So your compounds of interest will be aluminium and the aluminium oxide. So you state here, from here you can see that 4 of this solid aluminium will give 2 of this aluminium oxide, right? So you can make a balance. 4 of 27 of aluminium give 2 of so the 27 times 2 plus 16 times 3 of aluminium oxide. So it simply implies that 108 grams of aluminium will give 204 grams of aluminium oxide. With this, you can calculate the value of, or the mass of aluminium oxide that can be gotten when you use 27 grams of aluminium as contained in the question. So you can have your value here, maybe you can name it as y. So you cross multiply. 108y is equal to 27 times 204. You don't have to bother multiplying, just simplify. This will cancel this, then 27 here, 1, 27 here is 4, and you can divide this. 4 into 4 is 1, 4 into 20 is 5, and 4 into 4 is 1. So we are left with 1 gram of aluminium oxide. But then what we were asked is the number of moles of aluminium. So number of moles is equal to reactant mass over molar mass, right? So here we are going to have 51 grams of aluminium oxide over its molar mass. Its molar mass is this 27 times 2 plus 16 times 3. 27 times 2 is 54 and 16 times 3 is 48. When you add them together, it will give you 102. So you have 102 grams per mole. When you divide this to give you 1 over 2 mole, which is 0.5 moles. So your answer is A. Next is question 38, which says, which of the following periodic properties increases down the group? A. Ionic radius, B. Electron affinity, C. electronegativity, and D. ionization energy. Now, as we are supposed to know, in the periodic table is arranged according to masses or atomic number. And as you go down the group, all of the ions or all of the atoms have the same charge, but then the number of shells increases due to the increase in the atomic number. So this implies that the radius will be increasing down the group. So your answer here is A, ionic radius. And next we have question 39, which says, which of the following class of compounds can exist as dipolar ions in a solution? We have A. Alkanoic acids, B. Amino acids, C. Carbohydrates, and D. Dialkanoic acids. One of the peculiarities of amino acids is that when they are dissolved in a solution, they actually form both positive and negative ions, and they are called Zwitter ions or Zwitter ions. So your answer here is B, amino acids. And the last question is, which of the following properties of alkenes does not increase as the relative molecular mass increases? A. We have boiling point, B. Flammability, C. Melting point, and D. Viscosity. Of course, viscosity will increase as relative molecular mass increases due to the increase in weight, likewise the melting point and the boiling point. As for flammability, no, it doesn't increase as the relative molecular mass increases. Therefore, your answer is B, flammability. With this, we've come to the end of this session. So good luck in your exams and thank you for your attention.